All right, good morning and welcome to Master Talker online class. In today's video, we'll be talking about differentiation by first principle, right? Now let us consider that y is a function of x, right? If y is a function of x, now let us say let us take let's take that change in y, okay, or change in x is a small distance from y, right? I cannot start drawing the diagram for you, okay? But let me just show you how it works. And let us add a small distance, okay, to both sides by saying that y plus change in y is equal to what? F of x plus change in x, right? We added a little distance to the both of them. Now, let us take this man to this side and see what happened, okay? Or we can decide to subtract equation 1 from 2. But let me just collect like terms. Let me just take it as collecting like terms. So I have that change in y, okay, is equal to what? F of x plus change in x, then minus y, right? Minus y, okay? Now the question is, what is y? If you remember that from the first listing that your y is f of x, your y is f of x, you're going to see that change in y is equal to f of x plus change in x, okay, minus f of x. All right. Now let us divide both sides by change in y. Divide both sides by change in x. Sorry. Okay. So I now have that change in y over change in x is equal to f of x plus change in x minus f of x all over change in x. All right. Now, another thing you do is now to take the limit. Okay. To get the differentiation, you take the limit. Let's take the the limit as that change in x approaches 0. So therefore, your dy dx, the differentiation by first principle, is simply the limit of this man. Okay, we're taking the limit of both sides. Okay, let's just take the limit of both sides before. Okay, let me just take the limit of both sides. Okay, we're taking the lim as change in x approaches 0 of change in y over change in x is equal to the lim of the lim as change in x approaches 0, okay, of f of x plus change in x minus f of x all over change in x. So you should note note that dy dx note that dy dx is simply the lim of change in as x approaches 0, as change in x approaches 0 of that change in y over change in x. Okay, so therefore, permit me to now finish it here. So therefore, my dy dx is simply the limit as change in x approaches 0 of that f of x plus change in x minus f of x all over change in x. Okay, so that is my differentiation. So let us solve some questions to illustrate that. Okay, when I solve some question, you understand better. Now, I have a question. By first principle, find the derivative of the following function with respect to x. They say by first principle, find the the derivative the derivatives of the following function with respect to x. Number one, they gave us number one, they said x. Number two, they said 3x plus 5. Number three, they said x squared. Okay. Number four, Number 4, they said 2x squared plus x plus 2. Okay. Number 5, 1 over 2x plus 1. Number 6, the square root of x minus 1. Okay, so let us solve these 6 questions. All right. So now look at this. The first one, number 1, said that that y is equal to x. Okay, if y is equal to x, don't forget the method. The method is simply to add change in y and change in x to both sides. Okay, so I'm going to y plus change in y is equal to what? X plus change in x. All right, this is very, very simple. So the next thing you do is just to take this one to this side. If I take this one to this side, I'm having that what? Change in y is equal to what? X plus change in x minus y. All right, taking this one to this side. Now I have that change in y is equal to what? X plus change in x. Don't forget that your y is x, so minus x. Right, x minus x is gone, so I'm left with change in y is equal to what? Change in x. Now if I divide both sides by change in x, because I need change in y over change in x. Okay, so if I divide both sides by change in x, I'm going to have that change in y divide both sides by change in x. So I'm going to have change in y over change in x is equal to change in x over what? Change in x. And anything divided by itself is 1. So this is change in y over change in x is equal to what? 1. So the y dx I'm looking for, don't forget that dy dx is simply the limit as change in x approaches 0 of that change in y over change in x. Okay, which is what? The limit as change in x approaches 0 of 1. And the answer is what? 1. So the differentiation of x is 1. If you have not watched our video on limit, please do that. It will help you to understand better. Okay, so now let's go to question number 2. So question number 2, let me clean here. So question number 2 said that y now is equal to what? 3x plus 5. Now what do we do? The same thing. Anywhere you see x, add change in x to it. Anywhere you see y, add change in y to it. So I have y plus change in y is equal to what? 3 in bracket of x plus what? Change in x, right? Then plus 5. So what do we do? Let us open bracket. I have that y plus change in y is equal to what? 3x plus 3 change in x, then plus 5. All right. So the next thing we do is to collect item. This one will move here. If this one is moving here, I'm going to have that change in y is equal to 3x plus 3 change in x plus 5, then minus y. Okay, don't forget what is your y. This is my y. I'm going to have that change in y is equal to 3x plus 3 change in x plus 5 minus 3x plus what? 5. So I'm going to have that change in y is equal to what? 3x plus 3 change in x plus 5 minus 3x minus 5. If you look at this, you see that 3x minus 3x is gone and 5 minus 5 is gone. So I am left with change in y is equal to what? 3 change in what? X. So divide both sides by change in x. Divide both sides by change in x. So I'm going to have that change in y over change in x is equal to what? 3 change in x over what? Change in y, change in x. So if change in x cancel change in x, I'm left with what? 3. So don't forget that your dy dx is simply the limit as change in x approaches 0 of change in y over what? Change in x, change in x, which is what? The limit as change in x approaches 0 of 3, which the answer is what? 3. So the differentiation of this is 3. The differentiation of that is 3. So let's go to the next question. Question number 3. Question number 3. I hope I'm not too fast. Question number 3 said, question number 3 said that y is equal to x squared. So what do? Just add change in y and change in x to anywhere you see y and anywhere you see x. So I'm going to have that what? Y plus change in y is equal to what? X plus change in x. But it has squares, so I'm going to say all squared. All right. Now let us clear the bracket. I'm going to have y plus change in y is equal to now when this thing, when you want to play the, when this thing multiply itself, you are going to have x squared plus 2x change in x, then plus change in x all squared. Okay, so that is the expansion. Now this one need to move to this side. If this one is moving to this side, I'm going to have that change in y is equal to what? X squared plus 2x change in x plus change in x all squared minus y. Okay, so change in y will now be x squared plus 2x change in x, right? Then plus what do we have? What do we have? Change in x all squared minus what is my y? My y is x squared. So if this one cancel this, because x squared minus x squared is gone, so if they cancel out, I'll be left with what? Change in y is equal to this, and this is gone. I'm left with 2x change in x plus change in x all squared. So if I divide everybody by change in x, divide through by change in x. So I'm going to have change in y over change in x is equal to what? 2x change in x over what? Change in x plus change in x all squared, change in x all squared over what? Change in x. So now you will now see that my change in y over change in x is now equal to this. Cancel this, I'm left with what? 2x plus change in x, because this is cancel one of these. So now don't forget that my dy dx is simply the limit as change in x approaches 0 of that change in y over change in x, which is what? The limit as change in x approaches 0 of that 2x plus change in x. So now limit simply means we should substitute. Anywhere we see change in x, put 0. So if I put 0 here, my answer will now be 2x plus 0, which is equal to what? 2x. So the differentiation of x squared is simply what? 2x. You see that that is very simple to calculate. So we move to the next question. Question number We move to the next question, question number 4. And question number 4 said that y is equal to 2x squared plus x plus 2. Right? It's very simple. Just add change in x to the side of x and add change in y to the side of y. So I'm going to have y plus change in y is equal to what? 2 in bracket of x plus change in x all squared plus x plus change in x plus what? Change in x, then plus 2. Anywhere you see x, you must add change in x. I saw x here, I added change in x. Because it has squared, I put my squared. I saw x here, I added change in x to it. Right? Let me put it this way so that you know that they are together. So the next thing we do is to expand. If I expand, I'm going to have y plus change in y is equal to what? 2 in bracket of x squared plus 2 change in x plus change in x all squared, right? Like this. Then plus x plus change in x plus 2. So what do we now do? Collect items. Let this one stay alone. This one will move here. So, but before that, I'm going to have that y plus change in y is equal to this time this, 2x squared, this time this, plus 4 change in x, this time this, plus 2 change in x all squared, then plus x plus change in x plus 2. All right. So now, if you look at it, you're going to see that this one will now move to this side to have that change in y is equal to what? 2x squared plus 4 change in x plus 2 in bracket of change in x squared plus x plus change in x plus 2, then minus y. All right. Don't forget, I know what is my y. So change in y will be equal to what? 2x squared. But let me arrange it very well so that they will subtract. Or you just write it 2x squared plus 4 change in x plus 2 in bracket of change in x all squared plus x plus change in x plus 2 minus everybody here. So it will be minus 2x squared plus x plus 2, right? So now, this is now change in y is equal to what? 2x squared plus 4 change in x plus 2 uh, plus 2 in bracket of change in x all squared plus x plus change in x plus 2, then minus 2x squared minus x minus 2. If you look at this, x squared minus 2x squared minus 2x squared is gone, then x and minus x is gone, then 2 and minus 2 is gone. So I'm left with change in y is equal to 4 change in x plus 2 in bracket of change in x all squared, which other one? Plus change in x. That's what I'm left with. So the next thing you do is you divide everybody by change in x. Divide through by change in x. So I'm going to have change in y over change in x is equal to what? 4 change in x over change in x plus 2 change in x all squared over change in x, then plus change in x over change in x. So this is now change in y over change in x is equal to, this take care of this, I'm having 4 here. This take care of this, I'm having plus 2 change in x. Then this take care of this, I'm going to have 1. So finally, I'm going to have that dy dx that I'm looking for. You will tell them, let me finish it up here, that dy dx that you're looking for is simply the limit as change in x approaches 0 of this function, of this change in y over change in x, okay, which is equal to the limit as change in x approaches 0 of 4 plus 2 change in x plus 1. Okay, I think there is a mistake somewhere. Sorry, this is square the first one. I have this, multiply this and this doubly, so it's going to be 2x change in x. Sorry, this is 2x change in x, so it's going to be 4x change in x. Sorry, 4x change in x. So I'm going to have 4x change in x. So this is 4x change in x. Sorry about that. 4x change in x. So just carry this thing and expand it. You see that it's supposed to be 2x change in x. All right. So x should be here. So x should be here. Then x should be here. So x should be here. So if you now substitute 0 anywhere you see change in x, you're going to be having 4x plus 2 in bracket of 0 plus 1. So my answer is now 4x plus 1. So the differentiation of this is simply what? 4x plus 1. All right. If you know the normal differentiation, you will know that it is the same thing, because differentiation simply means multiply by the power and remove 1 from the power. So if you want to do it straight, you have that dy dx is simply multiply by the power, remove 1 from the power. You have what? 4x. But the coefficient of this is 1, so this is 1. Now watch my video on standard derivatives. Okay, yes, using general formula to solve differentiation. So you can do that to help you to understand what I just did. But this one I'm using now is by first principle. By first principle. So let's go to the next one. Question number 5. Question number 5 said 1 over, y is equal to 1 over 2x plus 1. All right. The same thing is applicable. There is nothing else to do, just to add x, add change in x and change in y to anywhere you see y and x. So I'm going to have y plus change in y is equal to 1 over 2 brackets x plus change in x, then plus 1. All right. So this one coming here, you're going to have, okay. So this one coming here, you're going to have that, this one coming here, you're going to have that change in y is equal to what? 1 over 2 brackets x plus change in x, okay, plus 1, then minus y, okay. So I'm going to have that change in y is equal to what? 1 over 2x plus 2 change in x plus 1 minus 1 over 2x plus 1. All right. So now, let us go by LCM. Let us solve the fraction. If we solve the fraction, we are going to have that change in y is equal to what? LCM is the two of them. LCM is 2x. Um, LCM is 2x plus 1 plus 2 change in x, okay, and 2x plus 1. When these two divide this, I have this. This time this, I'm going to have 2x plus 1 minus in bracket of 2x plus 1 plus 2 change in x. Okay, so this is now that change in y is now equal to 2x plus 1 minus 2x minus 1 minus 2 change in x all over 2x plus 1 plus 2 change in x, then into 2x plus 1. Now, this we cancel this, y1 we cancel minus 1. So I am left with change in y is equal to what? Minus 2 change in x all over 2x plus 1, uh, 2x plus 1 plus change in x, all right, then into 2x plus 1. So, getting to this point, I'm going to multiply everybody by, that is, divide by change in y, now change in x, our normal method, divide by change in x, okay. So permit me to finish it off this side. So if I divide by change in x, I'm going to have that change in y over change in x is equal to uh, minus 2 change in x all over what? Change in x in bracket of all these people, because I'm dividing with change in x. So in bracket of 2x plus 1 plus change in x, all right, then into 2x plus 1. Okay, so if you look at this, you see that this one will take care of this. So I'm going to have that change in y over change in x is equal to minus 2 all over 2x plus 1, 2x plus 1 plus change in x, all right, 2x plus 1 plus change in x into 2x plus 1. So now, the dy dx is simply to take the limit. So you now say that the limit as change in x, dy dx is equal to what? The limit as change in x approaches 0 of change in y over change in x, which is equal to the limit as change in x approaches 0 of all these people here, of minus 2 all over 2x plus 1 plus change in x, then into 2x plus 1. So if you substitute the 0, here, you will be left with minus 2 all over what? 2x plus 1 times another 2x plus 1. So which will give you minus 2 all over 2x plus 1 all squared. So that is the differentiation of that. All right. To differentiate this is what you are going to get. So the last question here. So the last question said that y is equal to the square root of x minus 1. All right? Y is equal to the square root of x minus 1. So let us do the same thing again. Add changing y to the side of y and changing x to the side of x. So I'm going to have y plus changing y is equal to the square root of what? X plus changing x minus 1. All right? So the next thing we do is let this man go to this side. I'm going to have that change in y is equal to the square root of x plus change in x minus 1, okay, minus y, which is what? Change in y will now be what? The square root of x plus change in x minus 1 minus the square root of x minus 1. All right? So the next thing you do is now whenever it is solved, what you do is simply multiply both sides by the conjugate of this. Okay? Yes, in form of rationalization, so that um, it will help, because addition and subtraction of sort, there must be like terms before they can subtract or add. So what I'm going to do is to multiply both sides by the conjugate. Okay, multiply both sides by the conjugate. That's what I'm going to do. Conjugate of this. So you say multiply by the conjugate, like multiply up and down by the conjugate. Okay, that's as good as saying multiplying by, okay, let us just multiply by 1. You know that anything multiplied by 1 is the same thing. But so now let me say changing y is equal to what? So the square root of x plus changing x minus 1 minus the square root of x minus 1, then times. I know that anything divided by itself is 1. 1 times this thing is still the same thing, but anything divided by itself is 1. So let me put this thing, the conjugate of this thing, into itself. You understand the ratio of it? So I'm going to have the square root of x plus change in x minus 1 plus, you know that this is minus, so the conjugate is going to be plus. So don't forget I'm still having this like this. So plus the square root of what? X minus 1, okay, all over the same thing. The square root of x plus change in x minus 1 plus the square root of x minus 1, okay. So anything divided by itself is still giving me 1. So why I need to do that is when I multiply, you know that this is now difference of two squares. And difference of two squares means the first person all squared, x plus change in x minus 1 all squared minus the other one squared, x minus 1 all squared. Then all over, what is now remaining here is now the square root of, so the square root of x plus change in x minus 1 plus the square root of what? X minus 1. Okay? So now, so this is now, don't know where to finish it off. My board is too small. So this is now equal to square root will take care of square. So I'm left with what? X plus change in x minus 1. Okay? Then minus x minus 1 all over the square root of x plus change in x minus 1 plus the square root of x minus 1. So this will take care of this, and minus, okay, minus 1 will give you minus 2. So sorry, minus to make it plus. There is a minus here, so this is going to be plus, or let me say in bracket of like this. So minus this will take care of this one, minus this plus this will take care of this one. So I am left with, please permit me to clean this place. I hope you have written it. So I'm left with change in y is equal to the only thing remaining up here is change in x. So change in x all over, changing x all over the square root of x plus changing x, right, minus 1, okay, plus the square root of x minus 1. So now if I divide both sides by changing x, divide by changing x, so I'm going to have changing y, changing y over changing x is equal to what? Changing x all over changing x, changing x in bracket of all these people, in bracket of the square root of x plus changing x minus 1, then plus the square root of x minus 1. So this will now cancel this. So I am left with change in y over change in x, right? Change in y over change in x is equal to um so is equal to, what am I saying? 1 1 over the square root of x plus change in x minus 1, then plus the square root of x minus 1. So getting to this point, you can now take the limit. So you now say that dy dx is simply the limit as change in x approaches 0 of change in y over what? Change in x, which is what? The limit as change in x approaches 0 of 1 over the square root of x plus change in x minus 1, okay, plus the square root of x minus 1. So if you now substitute change in x to be 0, so I am left with, permit me to continue from here. So I am left with dy dx is simply 1 over the square root of x minus 1 plus the square root of x minus 1. So you see, they are now like sword, and like sword can add. So this is now 2 the square root of x minus 1. So this is now the differentiation of that, right? So thank you very much for watching. Please don't forget to like, share, and subscribe. Bye bye.